We are going to be talking about classification and clustering. Before this, we have seen regression. Within regression, we have seen linear regression. We have seen multiple linear, and we have seen logistic. Logistic regression is a kind of, well, it is definitely a way of classifying your data between 1 and 0, yes or no, 2 or 4, right, between two values. And in a similar way, so that is basically what you call, in simple terms, is classification. The difference, classification and clustering are very much similar. Why? In classification, you have labeled information in classification. In clustering, you don't have labeled information. So when we see the prostate cancer data, okay, when we see this data, you see this classification. This is already classified. And what you are doing is you are building a model, you are training a model for which, or rather using which, anybody who gives this information, you are building a model using all these parameters which you see over here. You're building a model using radius, texture, parameter. So tomorrow, if anybody gives you data related to these 8 fields, these 8 data elements, you should be able to tell them that there is 80% chance this is malignant or this is benign. Make sense? That is what you're doing in terms of classification. Now let's look at the iris data assignment that we had. Right? When we had this data. Okay. We had iris data, we had seen this data, and over here when you see this information, you have these three classifications, you have these three values. Okay, just one second. So we are trying to classify based on these three values, or rather based on these four values, into these three groups. Iris is a kind of flower. Based on the petal size and the petal length, we are classifying that this is a kind of, what is the variety of that flower. Okay, again, this is also classification. In clustering, what happens is you do not have these labels. So when the first time when you see this information, you do not have these labels. So what practically happens, you create logical groups based on whatever information you have. Okay, you do not have these labels, you are going to mathematically create these groups, and that is what we are going to see how that is done. Understood till here? Never tried on Excel. So let's say I'm taking this information. Okay, I'm going to take this information and we are going to try and do clustering of this information. You see the different groups over here, right? You already have these labels. And here I have one particular new value for which I do not know what is the sepal with, I do not know what should be that particular species. Alright. Clear till now? What we have done, we are just taking data and we are going to try and do, rather create the logic for k nearest neighbor. Practically what happens in terms of k nearest neighbor when we look at the information, okay, you have something, you are going to create a logic. Okay, so I have these 2 points. Tomorrow if I add a point over here, let's say this is thumbs up, this is gold spot. If I add a point over here, where do you think it would be? Where do you, if just looking at it visually, where would you put it? The green is thumbs up, the blue is gold spot. So if I plot a point over here, where do you think you would put that point?
Gold spot.
Why gold spot?
It's closer to the blue than the green, right?
Yes. So logically, when you look at it, you're trying to take or put it in a group which is nearer to it, right? That's how it works. Even in your class, when you try and form groups, you try and form groups with your friends mostly, right? That's where you find that, okay, we gel well, that is why you form a group. In the same way over here in these points, uh, you can group, you can create logical groupings. Again, this is based on a specific label over here. You know the label information. Tomorrow, so that is what we're going to take. The first step. Right? We have this point. So like you said, it is nearer. So how would you calculate that this point is nearer to this point or to this point? How do you find that out? Any idea?
Euclidean distance.
Very good. Anybody has heard of the term Euclidean distance?
Yeah, during our class.
Which class? नहीं स्कूल में पढ़ा था क्या?
नहीं,
स्कूल में नहीं पढ़ा था. स्कूल में कैसे नहीं पढ़ा?
बिजनेस स्टैटिस्टिक्स में पढ़ा था. नहीं, मार्केट रिसर्च में.
Okay. So Euclidean distance is calculate a distance between these 2 points, x and y. Okay, you have these 2 points. So I choose 3 endpoints. I choose 3 points nearer to it, any 3 points, and find out which is nearer to these 2 points. All right. So in order to find the distance between these 2 points, I use the formula this way. You might have studied this in geometry in school.
Yeah, yeah.
Yeah, so before business statistics also, I'm pretty sure you studied this in school. So the formula is between these 2 points is x2 minus x1 the whole square plus y2 minus the y1 the whole square and under the square root of, okay, square root of these 2 points. Calculate Euclidean distance. Yes, सही जवाब. Right?
So I have a question.
Yes.
So the data which you discussed in the last class, the fish data, was also very similar to the data which is there in this iris.
Yeah. What? Let me open the data. Why is it doing it this way? Yeah, this is the weight of the fish. Yes.
Yeah.
Yeah.
So can you use classification in this?
This is a classification problem only. You can use classification. You want to classify the species. Here we were calculating the weight. We were predicting the weight. So there we were only using whatever information we have. Now we can even use classification. That if I have all these information, I can classify this data.
Right.
Remaining using all the other values, we were trying to find out the weight. So there we are using linear regression, multiple linear regression, or any other way of finding that value. So this can also be a classification problem.
So, but if we were doing multiple linear regression only, then why did we change all the species to 0, 1, matlab 0 or
This
1?
has a value. Now this also has a meaning. This bream, if I look at bream, you will find a specific range in terms of the size of the fish, right? There will be a specific range of that. Then for this also, you will find this range of the weight. So that is important if you want to find out the weight.
Okay, okay.
Yes.
Yeah.
So if you go to a wedding, and there when you look at the type of food, you can easily classify, right? Okay, this is a Maharashtrian wedding, this is a South Indian wedding, this is a Gujarati wedding, right? So in that sense, looking at that, you can say these are all those parameters. Tomorrow if they say what is the number of people you want to predict based on the type of wedding, you will require other information. So there you will be, since you're predicting a number, that is where you use regression primarily. If you want to predict a yes or no value, or you want to find out a group, you want to predict a particular group, that is where you use classification. Make sense? So what we are going to do, so I have these 2 points. Okay, let's plot. Let's see color. Plot. Let's try this. No. I'm going to sort this, by the way. Let me just sort this first by species. Let's see if something happens better. Nothing happened. Sorry. I have to do it this way only. Next. One minute now. 3.7, 3.3. Right, this way. So this is my data. Okay, the yellow point is what we are predicting. This yellow point is the point we want to predict, or we want to classify rather, not predict. So now if I change this, I make this minimum 2, I make this 4. Now can you tell me where, what is nearer to? Just looking at this, can you tell me what is it nearer to? Anybody else? Blue, red, green, yellow. Anybody has a preference of the color?
Blue.
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 Very good. Right. So it is blue. Yes. Majority wins. 3 people said blue. Okay, but let's try and find out whether it is really blue or no. So what are we going to do? We are going to find out the Euclidean distance of this point with all of these other points. Okay. This is my length and sepal width. I am going to find out the sepal, the difference, Euclidean distance. I don't remember the spelling properly, so that is why I am writing E distance. Pardon me for that. Okay. What was Euclidean distance?
x2
Is
minus x1 the whole square minus y2 minus y1 the whole square, the whole under root.
yes, this minus this.
Plus or minus? It's plus.
Under the root is plus.
Okay, okay.
Right. So this is what I get. So I want to freeze H and I. I freeze H and I. And I calculate this for all these values. And still here, I calculated the Euclidean distance for each of these points. And you want to find out where the distance is minimum. So I'm going to put a formula. I'm going to put a formula rank. Okay, I know the species also over here. I could use the formula rank. Rank. Rank this number, the reference, this order. We want ascending. So again over here I'm going to freeze this. Okay, now let's find out what is the species name over here. So technically I mean I can just copy this over here, but I want it over here. Let's say I want to find out the first 3 values. Okay, top 3 top n values. I want to find out 1, 2, and 3. This is like this. I want to find out the top 3 values. I take the species name and I can do VLOOKUP. Actually, I can even do even if I don't have this here, right? Even if I don't have this, I can actually use the latest function of Excel called XLOOKUP. So I take this value, lookup value, the lookup array. Where is the lookup array? A minute. Formula XLOOKUP.
सर पूरा कॉलम
हाँ, पूरा कॉलम ये है XLOOKUP के लिए, रिटर्न अरे ये है. Okay, so you get this setosa. In that same way, I can calculate for make sense now. These three are all. It is nearer to setosa, more nearer to setosa. So when I say k nearest neighbor, you are trying to find out how near are these points, or is this value nearer to, right? How near is this point as compared to the other points, and that k indicates the number of points you want to compare it with. So in this case, the k value is 3. I want to find out how near is it to the nearest 3 points. So that is what I am finding out. So if I make this 4, okay, let's say I make this 4 and I do this, I get versicolor. Okay, so versicolor, the value is, must be this one. No, origin is here. Okay, it's here. Understood what we have done? We have leveraged a logic in terms of, we have plotted these points in x and y, and we are trying to find out how close is this point yellow as compared to others. We can increase the marker size actually. You can change the marker also if you want to just you see this, how close is this one point as compared to the others. So it's finding out probably this is close, this is the point where it is finding the distance much nearer to it. Got it? You understood the logic of KNN? K is indicating how many, which are the 3 points which are near to you. The 3 value is K.
So, but why did you say that the versicolor one is the nearest?
It is the 4th nearest.
So K will be 1, no? The species which comes first.
Not first. You're taking that all 3 are this. If it was, you should always take a value which is odd, or you should not take a number of K as even. You should always take the value as odd primarily. Otherwise, you might have an issue in terms of taking distance. So it's like in the top 3 are setosa. Even then, even if the 4th value is versicolor, so here, right? See, the 5th value is virginica. I take the 6th value now, which is the 6th value, setosa. So out of these 6, still setosa is much nearer to this. That is why this point will be classified as setosa. It is not just taking the first value. There is no point of then calculating the other values like this. You have to take that K value, right? If K is 3, out of these 3, where is this point nearest to. You're basing your decision based on these 3 points, not on just one point, the first.
Okay. So the number of times, if it's recurring the maximum number of times, then that
Yes.
is the value, right?
Yes, it's nearer to more points of this group. Okay,
Yeah.
in that sense. Understood this? Everybody understood the logic of K?
Yes, sir.
Very good. So now we look at the logic of K means. Okay, we look at the logic of K means in a similar way. Okay. Now in K means, like I mentioned, you will not have these labels. These labels are not going to be there. These are the points which you saw, Setosa, all those points. K means is how many clusters can be there. When I look at this data, can you just looking at this data, can you find out how many clusters are there? Do you see some clusters? Yes. Which clusters do you see?
So there are like two parts in which these points are divided, the left
Yeah,
side
I
and
mean,
the
I
right
can
side.
actually group it into multiple. Like, see, these points are similar. I can actually group
Hmm.
something like this. I can group something like this. Right, but I do not know the meaning of this data. I mean, I have some parameters. I just plotted the value. So if I want to group these two, right? If I want to group them into two clusters or three clusters for that matter, I will take two random points. I'm going to just take two random points like this, and I am going to say that these points fall in. I I am going to break it. Basically, I'm going to draw a horizontal across this line. I'm going to split it across this line. Make sense or no? If I have 2 points over here, okay, when I plot these points, let's say I just assume I don't have these labels. Assume you don't have these labels. Okay. Okay. Okay, assume I don't have these labels. I can just clearly see two groups over here, right? I can just make out that this is possibly one group, this is one group, and this is one group, right? Is that correct? Do you see those three groups like this? All are all are blue. Okay, yeah. अभी blue अभी दिखा है, ऊपर blue लिखा, अभी blue दिखा मुझे वाह. Very slow. This is okay. But how do I do that mathematically? The way to do that mathematically is using the concept of centroids. You heard of centroid? The center point of a triangle. You might have heard that.
Yes, sir.
That is what we'll do. What we do is we take a center point like this over here and another center point like this over here. Okay, so if I just copy this, okay, what I'm going to do first is I'm going to draw a centroid. I draw one centroid like this. Let's say it's just two values. Okay, let's for simplicity perspective, let's say these are just two values, and I take another point over here. Okay, what I will do is I will change the color of this centroid so that it's not confusing. I will draw a line between these 2 points, horizontal line, and let's say I take it here. Okay. Just for this, if I take a line like this, okay, I'm just assuming a point like this. What I will do, I will now draw a perpendicular line from the center of this point. I'm going to draw a line perpendicular to this. You know perpendicular तो मालूम है ना क्या होता है? सही जवाब, धन्यवाद. Okay. You see, now what happens is we first assume that these are the points as part of this. I mean, just looking at it, and we assume the center point like this. So we are getting a group in this fashion. We are kind of creating now two groups, that whatever is on the right hand side of this line and whatever is on the left hand side of this line is your group 1. This is my group 2. This is the first step. Okay, understood till here?
So why can't I see 4 groups? Why just 2?
So you can do 4. I don't want to draw so much over here.
No, in this perpendicular that you've drawn, you can see 4 quadrants, no?
Array, you are just to divide it into 2, you are just taking the horizontal point. If I remove this line is just for the so that I can find out the centroid, so that I can find out the midpoint of these two lines and split it into 2.
But sir, this perpendicular can be anywhere depending on any 2 points I take, right?
Yeah,
So then how can you say that these only will be the 2 groups?
this is the first iteration.
Okay.
Yeah, this is your first iteration. There is also, if it is k means there has to be a meaning of k over here as well, right? So this is my first iteration. So the first step is to assume just 2 random points. I am not taking anything. I am just assuming 2 random points over here. Now what I will do is, once I have this information like this, I am going to calculate the centroid again of these points which you see over here and of these points which you see over here. When I do that, I'll get a centroid, let's say over here. I get the centroid, let's say over here. Okay. Now what I will do is, again I will draw that horizontal line between these two centroids. Again I'm going to draw a horizontal line between these two centroids and draw a line perpendicular to this. Understanding? Understanding? So here first this point was on the left hand side. Now this point is on the, I mean, opposite, right? This point which you see in the blue, this point over here is on the right hand side. Now this point has come on the left hand side. Make sense?
So is there any particular reason that we, I mean, like did it like this? The new point that we took, sir, what was the reason behind it?
No, I did not do anything. Basically, it depends on what values you assume over here, these 2 points. It's random. These values are assumed at a random basis. Okay. What you're trying to do is an iteration. What you're trying to find out is the centroid of all these points. What is the centroid of all these points? What is the center point of all these points? Once you find out the center point of all these points, because the first step we did not take any centroid, we just took 2 random points, that this is my centroid for this group, this is my centroid for the second group. I just take 2 any random points, after which I am going to find out the centroid of this splitted values. Once I find out the centroid of these 2 groups, that is the actual first step. Okay, once I have got the centroid, that this point has shifted. This was in my, let's put 1 over here. Now this center has become 2. It has shifted over here. So once I have it like this, I will notice automatically that this group on the right, this point on the right, has moved to the left. Understood or no? So I have not chosen it this way. It has, or I have not done any mathematical calculation at this point of time. When you see it in Excel, you will probably understand it a little better. Making sense or no?
Okay, sir.
No, if you not understood, let me know.
So what I'm not getting is that like you chose the first point as one we took there, the centroid.
Chosen randomly. This is not centroid. This is chosen randomly.
This is chosen randomly, sir. And for the second one, when you wanted to shift the perpendicular line so that the points they shift from left to right, sir. This was also random.
No, I have not done any calculation. I don't have the actual XYZ values over here. I have just plotted to show an iteration that one point might shift on the left or right.
Okay.
It is not that actually it has shifted. I have not done it mathematically at this point of time. I am just showing the iteration.
Okay, that's what I was not getting, sir. Okay, I mean, what was the reason behind the shift? Okay, sir.
We have to calculate the centroid of these points which are there. When you have drawn this line, right, you have to find out the centroid of these new points which are there in this group 1.
Okay.
Okay, so this was one iteration in a way. Now again, for these new points, I will find out the new centroid. And again, that might shift further. Okay, so now if I remove this point, and this point would shift over here, and this point might shift again back over here. Okay, and now I will delete here. This point, let's say it shifts over here. This point shifts over here. Okay, and this becomes my group like this. This is a horizontal perpendicular line from the center. So these are my 2 groups like this. You can see it. And again, if I see the iteration, yeah.
How many times do you keep doing this?
So there is a method called as elbow method, using which you can find out how many times you should do this. I will show that to you in Python.
So every position is actually the centroid that you have calculated of the points in that particular quadrant, right?
Yes, in that particular group, yes.
Yeah, okay, understood.
So let's go back to Excel and let's understand this little better. Okay. I'm just going to take these three values. I just kept it for the sake of keeping it over here. Let's do it two clusters first. Yeah. I'll just show you in a smaller group just to explain, because the steps are a little bit more complicated in this. Not that it isn't that different. Okay. So first I choose clusters. We want two clusters, one cluster and two clusters. For that I am choosing just any random point. I'm just choosing the same point, that this is the center of those two, the center, whatever that value is, right? I'm just choosing it this way. I am just showing a logical calculation over here. I'm not using something grand to explain. I'm going to find out the absolute distance of these points, of all these points with these centers. Of all these points with these centers. Okay, you know what is absolute distance? You used absolute. What is absolute? ABS. Have you used this?
Yeah, non-negative.
Yes. So I take this plus yes, this minus this ABS, this minus this plus bracket plus ABS, this minus this. Okay. Now I'm going to fix the center centroid value. This is my distance from C1. Rather, this is 1, this is 2. Okay. Now if I repeat this, I get how close each point is from this cluster 1. Second I do is, in the same way, I repeat the formula for
Sir, how did you decide on using 7, 3.2, 4.7?
randomly.
And 4?
It's randomly, I've just chosen a value. You can choose anything that you want. I chose it because it goes to 2 iterations, so I can at least show you an output. Make sense till here? Now I find out what value is lower. I'm going to write an if statement. If this less than this, then 1 else 2. Right? That is what I'm assuming, that is what I've written over here. Yep. I can do conditional formatting. Equal to 2.
So
Yes.
I'm a little lost. You said we will have two centroids for each, one for each group. Your this 7, 3.2, 4.7, 1.4 are also centroids only, right?
I've just chosen that this point, yeah, it is the centroid of this point. I have assumed that randomly for my calculation. This is my second centroid, the second value. Making sense or no? I have chosen two centroids for these two groups. Understood? Yes or no?
Yes.
When I look at this, I can see that this will fall in 1, this falls in 1, the green ones fall in 2. Got it till here?
Yes.
Yes. So now what I'm going to do, I'm just going to copy this. I'm just going to copy these clusters over here, because now what is going to happen is I am going to repeat this. I'm going to copy this value also over here. This is my first iteration. Now what I'm going to do is I'm going to change this formula of these clusters. I'm going to take an average of these points which I see over here. Okay. I'm going to take an average of these points. So here I see, I'll put 1 just so that I don't forget the formula. 1, 2, 1, 1, 2, 2. An average of 1. And for this average of now you see the difference. Now these points have changed. I'm just explaining it conceptually because I'm not using the centroid formula here. That is why I'm just explaining it in that way. I'm explaining it logically. So just bear with me for a minute. If you want to find out, right, you can find out the logical calculation of a centroid. You will come to this average only. The arithmetic mean. Notice that is why I'm taking an average. It is an arithmetic mean of the positions. Understood? So now I have taken this. Let's change this also. So now let's do iteration. Let's copy this data for iteration. This is my first iteration. I get the second iteration. I'm going to copy these clusters. I'm going to copy these two also. And now I will change this again. 1, 1, 1, 2, 2, 2. So I will change my average formula over here again. Again, I have to calculate the centroids. Right. So what will I do? I will do average of these 3 and I'll do average of these 4. So now you notice there is no change over here in these groups. So how much ever I go further, it is not going to change anything. So now I should stop at this iteration, because these groups are not going to change. Whatever I do, this average value is not going to change. So this centroid is not going to change. So now I have these groups, these 2 groups, that this is in one, this is in another. This data is in another group. Make sense? Did you understand the logic of how this is working? It means it is taking a. Did you understand the logic? Yes or no? सन्नाटा क्यों है भाई? कोई कंफ्यूजन है? हेलो. So you might be seeing this for the first time, which is why you might feel what is happening over here. But once you read it once or twice again, once you see this once or twice, you'll understand. It's basically just trying to group data logically. Right? So over here, in this group of points, is just trying to find the center of those points. That is what we are also trying to do. For these points, we're just trying to find the center of those points and finding out how far away each of these points are again in the next iteration. Make sense? What do you find easier, k-means or knn?
Sir, can you show that Excel sheet again just for 1 minute? Okay, sir.
I'll copy this Excel there also. Yeah, knn is easier because it is, you have the labeled information, but many times you might not have that labeled information. So if you remember, we had in Tableau. Okay. So if I look at Tableau, how do I kind of see this in Tableau? I'm just going to show that quickly to you. The logic is similar. Okay, same what is happening underlying in Tableau as well is going to be similar. So let's take this. Give me a minute. Excellent, excellent. Where did it go? Let's first look at K and N. That's very easy to understand actually. So I have sepal length. So what have I plotted on my X over here? Sepal length is Y. Okay. What I see, I change this again. This 4. I make this 2. And I can add species to color. When I see this, I see these groups. Yeah, this is what I have got over here. The same thing, right? I can increase the size if I want to. I can change this species to shape also if you want to. So here I can see this is one group, this is another group, this is a third group. So this is the same thing. This is what you're doing in terms of K means you're just trying to find out what is the nearest point. Okay. Now let's say I load this again. And this time I take this K means. In this K means I am going to plot. I'm just going to plot 2 points. I cannot plot all the 4. It will not make sense. So I am going to just plot in analytics. Yes. Yeah, you can actually easily just see these 2 points. Just looking at it, it makes uh, uh, I can see how it is. Okay. And here I see this cluster. If I drag this cluster over here, I can put 2 clusters and it will easily tell you these are the 2 clusters because the data is such. Okay. In this same way, if I repeat this sheet, I duplicate this sheet. Okay, I remove this color, I remove this species, I go to analytics and I put cluster over here and I say I want 3 clusters. Now you notice it has grouped these points in this way and these points in this way. So it has drawn a line like this, it has drawn a line like this, wherein it has found that these points have the same centroid. These points have the same centroid and it's not changing. That is where you have K and N. K means coming in. Make sense to a certain extent?
Yes, sir.
All right. So finally, I'm going to show you what. So some of the steps are same, obviously your data cleaning steps and everything. I'm going to show this k-means and knn using Python. Okay, so I am just taking these 2 points. reading this data. Okay, I read this data. So there was a, so I'm not explaining these steps because we have seen this earlier. There is a issue in the data because, rather not in, there was a data issue in this data, right? No, that was in the prostate cancer, sorry. That was not there in this. So I need to change the labels for this. Okay, for the label encoder. So I'm using this label encoder. So you see this label 0, 1, 2 in this case for iris 0, 1, 2. So when I print Y, it will show me 0, 1, 2. I am using this label encoder to encode these values of this variety into 0, 1 and 2. Okay, I get it this way. Now I'm setting the values of X, which is all these values, X, all these values, sepal length, sepal width, petal length, petal width. We have the value of X and we have the value of Y. Now what we need to do is pretty similar. We are going to use, so if I want to find out sklearn go to this API and here I can find out KNN. KNN, nearest neighbor, if I look at it. Notice K neighbor classification, K nearest neighbor classification. Okay, that is what we need. We need this K nearest neighbor classifier. Okay, K neighbors classifier. That is what we also need to import. So like in any of these values, we have these parameters. We are choosing the value of n over here 5. We want to check with 5 neighbors. I want to check with 5 neighbors for now. I'm not explaining this as of now. I'll explain these all these parameters again. I just want to show an output over here. Okay, but I will explain this again on Saturday or Sunday. So I have fitted this classifier and I can again, now for the confusion matrix, I can actually get the confusion matrix pretty easily. It's the same thing. Since it's in logistic regression also we saw this. Here also we are seeing this. So we are predicting the value of Y. We are classifying that and I am getting the confusion matrix. So here the confusion matrix is for these 3 values. That is why you see a 3 by 3 array. The earlier confusion matrix was only for 2 values. You would see an array of 2 by 2. Alright. So I have got this. This is my K nearest neighbor. What we try to do in Excel, I am getting, I use only so much information, but here we have used length of data set 150 rows and we are using K nearest neighbor. We are grouping those 3 values into these 3 clusters, rather classifiers, not clusters. And the score, right? The classifier score is 96%. So the accuracy is 96%. Got it? It's pretty simple. I need to change this value, this metric, n neighbors. Now in K means what I had told you, and again I'll explain this more in detail on Saturday or Sunday again, once again, because I think this is little confusing. Okay, so I have this again over here. When I look at this, I need to find out where is K means. Yeah, so I see this clustering dot K means. So I need to import that library of k-means. Here is the example. sklearn.cluster import k-means. So here again I need to import k-means. Okay, so just bear with me for some time. I will explain all these parameters again in detail. This is called the elbow method that I was telling you. It's running, it's trying to find out the value of the cluster. You see, as this goes ahead beyond 5, right, the value of is not changing. This is what we did, these iterations, we are trying to fit how many clusters should you use. I'm changing the value of these clusters 1, 2, 3. Based on that, this elbow is created. So here at this point it's kind of stopping. Okay, so there I'm going to use that value of 3 or 4 if you want to, but 3 is more, since we know that there are 3 clusters over here. Okay, so I have fitted the value of x over here, and finally in the same way what I get over here is k-means. Here I'm using these clusters. So using this elbow method, I'm finding out how many clusters should I use, and I'm predicting the value of y, that it falls in which cluster. Earlier you were giving y prediction is equal to, you're finding the predicted value of y. Here I'm finding the I don't have a labeled information, which is why I'm just directly finding the value of y over here. And when I plot this, these are all scatter plots. I have just changed the size of the uh, uh, labels, size of the values. Okay, and I'm also, this k-means gives me the centroids also. And when I plot this, I can see this is one cluster, I can see this is another cluster, and I can see the green as another cluster. Make sense? I know I ran a little bit fast on the Python piece, but I will repeat this again on Saturday. But I just wanted to give you an idea in terms of how, I mean, it's pretty easy when you understand the logic. You can easily see when you plot this value, you can easily see how the groups are formed over here. You got a high level idea? Hello?
Yes, so only the Excel thing. This Python thing I didn't understood.
So Python I will repeat. The steps are similar to all
Yes.
the Python I will again repeat. So this Saturday or Sunday we'll have the final session, and Python I will repeat this. I know this is, so what is important is to understand the logic. If you understand the logic, implementing that in Python is not an issue, because in all those modules that we saw, right, in all the Python modules that we have seen, the first step is to import the library, get a value of x, get a value of y, what you want to find out. You fit the model, you predict the model, or classify. It means you are clustering. These are the key steps, other than the data manipulation that you need to do. These are the key steps. If you look at all of those, if you compare all of the 4, right, you have taken this, you create a classifier, you're passing some parameters to that, you are fitting the classifier x comma y, and then you're predicting the value of the classifier. That is what all of those are doing. Even in logistic regression, linear regression, you are doing the same. You are taking the value of x, you are taking the value of y, you are fitting the model, predicting the model. Over here also, yeah, you're fitting the model, you're predicting the model, And in terms of k-means, the only thing you're doing differently is you're fitting and predicting together. See this? You fit, predict. Understood? The steps are same in Python. All these are the same steps. If you put it side by side, right? If I just take it side by side and just show it to you. Logistic. Yes, so let's look at this way. This is linear regression. Okay. This is logistic regression. I need to import this library. Then what do I need to do in this KNN? I'm importing this library from sklearn. Here I'm importing this library. What is the first step in linear regression? I can find out the value of x. I find out what is the value of y, right? Yes or no? Yes or no? I find out the value of x and y, right? For linear and logistic regression. Yes. Now over here, in terms of KNN also, I am finding the value of x and y because I have the values of x and y. In this, I just have the value of x. I do not have the value of y. Yeah, I do not have the value of y in terms of k-means. Now what do? I create a regressor, right? Over here, I create a regressor using this formula. I have created a regressor, so let's copy that also. Yeah, I create this regressor using linear regression. Here what do I create? Again, here also I create a regress classifier. I create classifier using logistic regression. In nearest neighbor, here also I am creating a classifier. And k means, okay, in k means I don't need any classifier. I just use this. Then what do? I predict y. Using this regressor, I am predicting the value of y. Rather, I fit the value. Regressor dot fit x comma y. X, y. Here, classifier dot fit. Here also classifier dot fit. Here I don't need to fit anything. I am just doing k means dot fit underscore predict, right? Both of them are together in this. After I have classifier, then I predict y. Y predict equal to classifier separate equal to regressor dot predict. and x based on x. Same over here. I am doing y predict is equal to classifier dot predict. Same over here. It is all similar. The steps are all similar. Does it make sense? All the steps are similar, and then you plot a graph in whatever way you want to. Is it clear?
Okay, sir.
You understood or no? तो ओके तो ठीक है, ओके बोल दिया, बट आपको समझ में आया नहीं समझ में आया अभी भी?
Sir, little bit.
Yeah, see, you understand linear regression and logistic regression, right?
Yes, sir.
Yes. And KNN you understood?
Yes, sir.
Yeah, even in Python, it is very much similar to logistic regression. You have to import a library. You need to decide what is X and Y. Create a classifier, same way over here. You fit the classifier, you predict the value of the classifier. The only difference in terms of K means is you don't have the value of Y. You do not know the value of Y, you have to decide the value of Y. Rather, you have to predict the value of Y in terms of what is the cluster. So here, you just have the step of fitting and predicting it together. So if you have understood to a certain extent, I will repeat this again the next and final session. But mathematically, if you understood the logic in Excel, this is not going to be that difficult to understand. Yeah, we just have to go through it once more and you will understand it. Okay.
Sir, will we be doing this CNN also?
No, I can explain CNN if you want to.
Okay, sir.
CNN is not KNN. CNN is convolutional neural network.
Yes, sir, that's what. After this, will we be doing CNN also after KNN?
No, it was not there in that, but I can explain it. That is not an issue.
Okay.
If you have understood all of these, if you understood these concepts, I can explain CNN also. And you can actually try it in Python. That is more complicated because it's a neural network. But I can explain that.
Okay, sir.
All right. Any other points? Any other questions? I will share these Excel. I will save the Python code and the Excel file so that you can just go through it once. The Python code is not much. Okay, it's very just literally 3 or 4 lines. It's more in terms of how have you understood the concept. So first we'll complete these. Practically the whatever is supposed to be covered is covered. We'll revise this again once, and after that then we'll look at CNN since you want to look at CNN. Okay. Any questions, guys? कोई विशेष टिप्पणी? Or we can call it a day. Yeah, I assume no questions.